Hey, this is Mr. Molo with lesson 3-7, graphing absolute value functions. So very similar to yesterday's lesson. So if you don't have your notes from yesterday, or you didn't write them down yet, I would go back and write them down. So some of this stuff might not make sense if you didn't take notes yesterday. This is pretty much exactly the same thing as yesterday, except now it's absolute value bars instead of parentheses. So it matters where the numbers are. Are they inside the absolute value bars or are they outside the absolute value bars? And that'll determine whether we're going up or down or left or right or wherever we're going. All right, so if we look here, we have 6 ones that are all pretty similar. They all have either a negative or a positive. They have a -2 or a +2. Sometimes that -2 is in front. Sometimes that -2 is behind the absolute value bars. So what does that all mean? So if I look here, I'm going to kind of do this process of elimination. I have a negative sign in front of A, in front of C, and in front of F. And so when we look at negative signs from yesterday, that means they were reflecting. So it's a little easier to see here if something reflects an absolute value because it's going to be an upside down one. So we know that those 3 that I just underlined are negative absolute values, so they're going to be upside down. So if I look here, this one has x -2. And it ends up being inside of the parentheses. So a -2 that's inside of the parentheses means it's just going to go to the right 2 spots. So -2 means right 2 inside the absolute value bars. So I'm looking for a graph that the vertex went right 2, and it's going to be D. So instead of it being, a 0 there, it went right 2 spots. So that one gets matched with D. All right, C here has same thing, the minus sign, so I'm looking for one that's upside down. It has a +2, so that meant that this -2 went right 2. This +2 means it's going to go left 2. And then it has this -2 on the outside. So that means it's going to end up going down 2. So I'm looking for a graph that's upside down because of the first negative sign, a graph that goes to the left 2 because of the +2, and a graph that goes down 2 because of the -2 at the end. And it looks like that one is going to be letter E. So instead of 0, 0, like we said, it's going to go left 2 and down 2, and that's our vertex of that graph. Okay, and the last one we could pretty much say is process of elimination, but let's go through it. So again, that negative sign is going to make it upside down. This one has a +2 as well inside the absolute value bar, so I know that's going to be a left 2. And then instead at the end, how letter C had a -2, this one has a +2. So that one's going to be an up 2 instead of a down 2. So they both have x +2 inside the absolute value bars. So they're both going left 2 spots. They both have a minus sign in front, so they're both going to be upside down. Except this one has a -2 on the end, and this one has a +2 on the end. So that means we're looking at letter B. So it still went left 2 spots, but now went up 2 spots there. So letter B. All right, now let's look at these other ones. So they should all be facing upwards since there's a positive, positive, positive. So those should all be good. And then here I have an x -2. So again, just like on A and, I guess just A so far. Just like on A, that means I'm going to be moving my graph right 2 spots. And this one has a +2, so just like F, that means I'm going to be moving up 2. So here I'm looking for a graph that moved right 2 and up 2. So 1, 2, right 2, and up 2 right there. So that one's going to be matched with graph C. Here I have an x -2, so now I can say it's like a couple ones we've done so far. So that x -2 is going to make it move right 2. And then this -2 on the end, just like on letter C there, is going to make it move down 2. So I'm looking for a graph that moved right 2 and down 2. And that's going to be letter F, right 2 and down 2. So letter F there. Here, if we look, there's a 2 in front of it. So that's actually going to give us a vertical stretch of 2. So if we look at the last remaining graph here, graph A, this one looks to be a little bit skinnier than all the other ones. You can see our slope is it's going up 2 over 1, up 2 over 1. Versus these are more like up 1 over 1, up 1 over 1. So this one's a little skinnier here, so that's what that 2 is doing. And then again, we have a -2 inside the parentheses. Or I'm sorry, this time it's absolute value bars. So that means we're going to end up moving right 2 spots. So 1, 2. and then it's a little skinnier, so stretch of 2. All right, there's only 4 examples here on this one, so we're actually going to end up looking at another sheet of paper here, but it says here that we have 1/2 x. So again, there's kind of a slow way to do this and a fast way to do this. We could plug in all these numbers here and make our graph. So absolute value of -4 is 4, half of 4 is 2, absolute value of -2 is 2, half of 2 is 1, half of 0 is 0, half of 2 is 1, and then half of 4 is 2. So I could graph all these. So -4, 2, -2, 1, 0, 0, 1, 2, and 4, 2, okay? Or I could have thought there's no plus or minus anywhere over here. There's no plus anything, so that means I'm pretty much starting at 0, and this here kind of tells me what my slope is. So that means I'm going to go up 1 over 2, up 1 over 2. And then same thing, since we're talking about absolute value, I can also go up 1, left 1, up 1, left 1, because that would give us the same thing. So there's kind of a fast way and a slow way to do this. That's going to be what our graph looks like. But depending on how it is with these numbers, we can kind of decide what it's going to do. All right, same thing here with number 2. So we don't see anything that's different except for this negative sign in front. So that means we're starting at 0. There's no plus or minus anything there. Our slope is 1 because it's 1x. And the only thing that this is telling me is that it's going to be a negative, which means it's going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. You could fill out the table and do that. I'm not saying that that's going to be wrong, but just a faster way to do it is just kind of to look at, see what's happening there. Okay, same thing here. This says absolute value of x minus 3. So remember that minus 3 when it's on the outside means it's going to be pushing my graph down 3 spots. So I'm not going to start at 0 here. I'm going to start down 3. Again, there's no slope here. There's nothing in front of the x. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. My graph's just going to look like that. All right. And then on this last one here, it's x plus 2. So now it's inside the absolute value bar. So now I know it's a horizontal translation. And remember, plus 2 ends up moving my graph to the left 2 spots. And again, no slope, no anything. So it's just going to be up 1 over 1, up 1 over 1. So a lot faster if we understand kind of the shortcuts I gave you yesterday and today with all that when we're talking about graphing. All right, so here it wants us to compare the graph to f of x, so same thing, and then it wants us to describe the domain and the range. Okay, so if I'm looking at this, I have absolute value of x minus 2, so that minus 2 is outside the absolute value bars, so that's going to end up moving my graph down 2 spots. So that's what that's going to do. Okay, domain, pretty much for all these, is going to be all real numbers. There's not a number that I can't put in for the domain that wouldn't make sense. My range, if you remember, is going to be my lowest point. So now that I know I'm down 2, my range is going to be anything greater than or equal to 2. There's no way it's going to get anything less than that. Okay. Same thing here with number 2. Let's do this one in green so we're not confused. Let's move this over here. Oops. Sorry about that. So we went down 2. There's our domain and range. Okay. So now if I look over here at number 2, so it has the absolute value of x plus 1. So do this one in green. So that plus 1 is going to make my graph move up 1. Again, domain is going to be all real numbers. There's not an issue of any number that we can't pick. And then our range here is going to be, since it's going up 1, and then going to be an upward facing graph, the lowest that we can go is 1. So y has to be something greater than or equal to 1. All right. Oops. All right. So let's look at something like 7 and 8. So here I have g of x equals absolute value of x plus k. So it knows that our graph moved, and it's even telling us, it's nice, it told us what the plus sign was there. So it moved how many spots up. And if you look here, it went from 0 to 1, 2, 3. So really that k is 3. Okay, same thing here. Looks like we're starting at 0, and we went over here to -2. So it looks like our h here, so it's asking how many spots did it move over. It moved over 2 spots. Okay, here they want us to write it out, so a little different. So a vertical translation up 2 spots, or sorry, up 4 spots. So then I'm going to have my g of x equals, so up 4 spots means it's outside the absolute value bars. So it's going to be the absolute value of x plus 4. Remember, if it said like left 4 or right 4, it'd be inside the absolute value bars. And then here we have a vertical stretch by a factor of 3. So here now, since that's a stretch by a factor of 3, that means my 3 is going to be outside my absolute value bars. And so it's the 3 times the absolute value of x. Again, nothing's over here. It doesn't have anything about like left or right or up or down. So the 3 is just going to be in front of the absolute value bars there. All right, I hope that helps.